Hello guys, this is Tanajin and welcome to my channel. In today's video, we'll talk about one more genius, which is Sir Stephen Hawking. Yes, so today is Sir Stephen Hawking's birthday. Actually, he was born in 1942, 8 January. And today we're going to talk about his achievements, his struggles, his life. Okay, so first let us start about his birth. He was born on 8 January 1942, as I've said. And 21 years later, when he was doing his higher studies, from the University of Oxford, there he had uh, kind of not a disease, you can say injury, which led to the motor neuron disease, where the entire body was paralyzed. So because of that, he had to we he had to kind of stop his work, but he did not. And then he did more work, and then doctors say he would live for only 2 years, but he lived for 50 years. So at that time, he did wonderful work in physics and astronomy. So we're going to discuss two of such works, which are very important in the entire black hole thermodynamics. So let us get started. First is our favorite, Hawking radiation. So according to Sir Stephen Hawking, black holes are not cool. They are actually warm and they are radiating energy. So what happens is, this is your event horizon. Okay. Okay. This is your event horizon. This is the event horizon. So as you can see, it has a lot of energy here. Okay. Now you know one thing from the Penrose diagram: antimatter, matter. Okay, matter, antimatter. Okay, they kind of collide to form photons. Okay, energy. Okay, when antimatter matter annihilates, it forms energy. Now from this energy, we can create matter, antimatter. We can have the reverse process. So here we have matter, here we have antimatter. So this is what is Hawking telling about, the Hawking radiation. The formula is temperature is equals to Boltzmann's constant. Sorry, not Boltzmann's constant. Planck's reduced constant divided by 8 by G m Boltzmann's constant. Okay. So here h cut is nothing but Planck's constant. If you know, it is h by 2 pi. C is speed of light. Pi g is the gravitational constant. M k is nothing but 1.3 times 10 to the power minus 2 3. The Boltzmann constant, which is mostly used in thermodynamics. This is the formula of Hawking radiation that Sir Stephen Hawking had given. The second contribution he gave was information and area. Okay, entropy and area. He said black holes don't have less energy. They in fact increase the energy, and they have information stored on their area. So it depends on their surface area. So we can call it as surface area. Okay, according to him, this is a black hole. Okay, so the black hole, the entropy of a black hole is depending on the Boltzmann constant multiplied by area divided by 4 Planck length square. Okay. So according to this formula, the entropy is directly proportional to the area. These all are constant. And this has been proven recently by the astronomical photographs. Sorry. That entropy and the surface area of a black hole are related. Now, if we talk about his books, he wrote many famous books like the Brief History of Time, and then the Universe in a Nutshell, and then we have a lot of books like answers to some questions, something like that. I've mentioned all the images of the book. Okay, so I love those books. I have one of the books. I'll show you if you want. This is the one of the book of Sir Stephen Hawking, A Brief History of Time. He has talked about in his book about a picture, and first he talks about first is the introduction of him by Carl Sagan, wonderful astrophysicist. And then we have our picture of universe, space and time, expanding universe, uncertainty principle, Heisenberg's, which I told you in my radioactivity and quantum tunneling video. And then the black holes aims for black. Here we have, and then we have the origin and fate of universe, arrow of time, unification of physics, and then we have about all the physicists. So if I tell you about the black hole chapter, okay, he talks about space time and spinning black holes, and this name Cygnus X1, and then he talks about what is this anti-medical experience. Oh, this is the Hawking radiation, I guess. Yes, Hawking radiation, and then he talks about gamma ray. Okay, where is gamma ray? Some graphs he has given. And then yeah, black holes aims for black. So this is from this end Hawking radiation part where he mentions about Hawking radiation as black holes not black. They keep on radiating or emitting energy. So this is about Stephen Hawking. I know it's short, but his contribution is so well in our physics. And then his dedication and determination led to what he is and what he is known today. Thank you. Goodbye.